Hi there. So we're going to take a look at Entity Framework and specifically Entity Framework Core. So I want to talk a little bit about what Entity Framework is. We could spend a lot of time doing a lot of videos just on an Entity Framework by itself. So this is going to be a really brief introduction. So let's take a quick look. First of all, it's what's known as Object Relational Mapping, and that should be 2 P's, not 3. And what that really is it'll create a set of classes or objects that represent the tables in the database at its simplest form. And it supports reading and updating data. So the idea here is that the developer doesn't need to know all the ins and outs of the database. And when you really get into ORMs at a more complete level, you really aren't dealing with individual tables. You're dealing more with like we do with REST with a resource. It's not really called a resource, but the class that you're dealing with may actually have multiple tables underneath it. And so it abstracts that complexity of having to deal with the database. And it allows developers to not have to work in the database at all, is really a driving force behind it. So normally we have our application code calling the database like this. And that application code may include ADO.NET, as we've been doing. But with an ORM, you have this intermediate layer in here that's basically abstracting that database into a set of objects that you use. And then your application code uses those objects. So you basically stay in an object-oriented programming world. You're never dipping off into, or you're not having to dive into the relational database world at all. So Entity Framework is a Microsoft ORM. There's lots of ORMs out there. There's ones that work with .NET technologies. I've written one before. A lot of people use these. It can be either code first or database first. And so what that means is if it's code first, we're going to write the code first, the ORM model, and we're going to generate the database from it. So this is a way to say, well, we're really going to be pure object oriented. We're going to build exactly what we want the database to look like. And then there's some work that you can do to optimize things in the database, because it can be a little bit inefficient to just say we're just going to use objects. Although with NoSQL databases, that may be a good choice. Database first means we already have a database, and this is kind of common if you've already got a database developed, like we do in our example. So then you use a tool to look at the database and generate the ORM model for you. So remember, in a model view controller architecture, the model represents the data, and the ORM in this case really builds that model for you. So we're going to be doing some major changes in our code, but it'll be pretty straightforward. And here's what we're going to do. We're going to install Entity Framework Core, and just like .NET Core is a slimmed down version of .NET, the Entity Framework Core works with .NET Core, is cross-platform, is open source. That also means there's some things that aren't available to it. For example, right now out of the box, it doesn't support views. Now, by the time you listen to this in a few weeks or months, since I've recorded this, it may support views. There's an open issue out there in GitHub to take care of that. But we're going to take a database first approach and generate the model from our database, and then we're going to change our code around get to demonstrate how we use the EF Core ORM. So that's what we're going to do. So let's jump in and do it. All right, so to start with, what we need to do is install some packages. And even if you already have the latest version of Visual Studio, you'll need to make sure that you've installed these. And so I'm going to go to the Package Manager console. So again, that was under Tools and NuGet Package Manager, and then the Package Manager console. And it responds with this PM prompt. And so here is what we're going to do first. We're going to say install -package Microsoft.entity framework core. Now we don't want to delve off into regular entity framework because if we want to maintain our compatibility with the things that we like about .NET Core. What this is going to do is install the appropriate database connectivity for SQL Server. There's other ones out there, so if you're using Oracle or another database, then you would use those database drivers, if you will, or packages. And I'll pause this while it's installing, unless it's done. The next thing we're going to do is install Microsoft Entity Framework Core Tools. So that'll install some of the tools we need, specifically the thing that generates the model for us from an existing database. So we'll let that run. Okay, next what we're going to do is we're going to actually build our model. Okay, so to do that, we say scaffold dash DB context. So what this says is, okay, I'm going to go look at this database, and what I'm going to fill in these double quotes is my database connection string. And then Microsoft Entity Framework Core SQL Server and we're going to output the models here. Okay, so I'm going to pause this. I'm going to go grab my database connection string and I'm going to drop it in here. Now I've got my password in here, so I'm not going to show this to you, but you would put your entire database connection string in here, the one that we have sitting over here in app settings. So that's the one that you should have. And there's a database connection string here, so I'm going to copy this entire string and put it inside those single quotes. So I'll be right back after I install that. Okay, so this command -output dir model says put it in the models folder. So what you'll notice was put in here is a model for each of our tables. So it actually looked at everything in the database and generated it. And let's open up one of these so you can see what they are. So this is what they look like. You basically have getters and setters on the properties. And there is an AdventureWorks LT context class. We use this before we do anything else. And right here, it's embedded your database connection string. And you'll notice here it has a warning to protect potentially sensitive information in your connection string. You should have a different way of doing this, and it points you to the place to do that. So make sure that you go in there in your database context and change that. Okay? And again, I've scrolled off the screen here so that you don't see the database password. Okay, so that's all you need to do with the package manager. So now let's actually use this code to do something. So let's look at our get. So we've generated a bunch of models that we're really not going to use. We're going to use address, customer, and customer address. We're going to use those three tables. And you'll remember that what we were doing before is we had a view defined in the database. We were making a call to get that view, and we had created a data layer to do all of that. I'm not going to move this entity framework code into the data layer at all. You'll want to do that though. You'll want to do that in order to keep this code clean, because you're going to see that I'm going to end up replicating some code in here. So it'd be better to have a class that dealt with this. So I'm going to take all of this code right here. I have 3 get routines. Address labels by themselves gets everything. Getting it by customer ID, and then getting it by postal code. We developed all of those over the last few videos. So I'm actually going to comment all this code out because I don't want to get rid of it. but I am going to replace it with a copy, and then we'll change the copy. Okay. So I just commented it out so that I have a backup. Okay. The first thing is we are not going to send back an enumerable address label set. Now, we could use Entity Framework to populate our models, but remember that the whole point of using Entity Framework is you don't have to build the models that we built. So we had built classes in here to take care of the address label here. This is not an Entity Framework class. This was our class that was already in there. And we built that so that we could return a list of or an enumerable of those. And so we're not going to do that. What we're going to return instead is something called a Json Result. And Entity Framework has the ability to convert things into JSON for us, which is great. We're not going to use these 2 lines of code at all because we're not using our data layer. So we're getting rid of all the data layer code and everything. And what we're going to do is we're going to get AdventureWorks context, and we're going to call that DB context equals new AdventureWorks LT context. So this gets a context, and remember this was this class we looked at that had the database connection string. So just think of this as exactly what it says it is, which is a context that we can use to then go ahead and use our Entity Framework. And then what we're going to do then is just create this thing called address labels. And then we're going to use some Entity Framework link code, LINQ code specifically. And I'm not going to go into details of exactly what this is, but what you're going to see me do here is basically build a join using the models that are already built here. So I'm not building a join in SQL. I'm building a join to join the tables that are these models that were code generated for us. So so what we'll say here is from, oops, let's do this. We'll do join. So these are just like SQL aliases. So we start out with the customer table, and we need to join that to the customer address table. And we're going to join that because we have this alias C that we just did. So we're going to do that on customer ID equals CA customer ID. And you'll notice the nice thing about Entity Framework is once you have these models, it knows all about these fields. So you have all those in IntelliSense. And then we need to join from that table to the address table. So address is the one we want on CA dot, and this is going to be address ID. And again, this is a big advantage of ORMs is you actually have at compile time your data, which is great. So address ID there, and then we do a select new, and then there's a bunch of code here I'm going to write, but basically what this says is we're going to return the same columns that we were doing before, the same same field names. So what I'm saying here is, hey, the stuff that you get back from this DB context customer ORM mapping of this table, call it customer ID. And the reason I'm doing this is I'm preserving compatibility with the JSON that we already built. So if we had clients that were already using this code, we wouldn't want to break them. And I'm going to go through and do all these fields. I'm going to pause while I do this so that you don't have to sit here and watch me type all of these. So I'll be right back. Okay, so I've typed all of these in, and you can see here's the fields that we were using before. I actually went to the database view and just used those same things. that we had defined. And then we want a parenthesis, or a closing parenthesis and a semicolon. Now, what we want to do then is, what do we return? Well, we need to return this JSON result, so it's pretty easy to do. We'll just return this new JSON result. And we just pass into it our entity framework object address labels. And that's all there is to it. So now our get should return the same thing. So what have we really accomplished here? Well, instead of having a view in SQL with the join in it, we've done all of that in code. Now we can argue back and forth as to whether it's better to have it in code or not, but I'll let you decide that. There's times when it makes sense, there are times when it doesn't. I think it's a good idea to not have to have developers have to have intimate knowledge of the database, but anytime you have any connection to a database, you have to worry about changes in the schema, and that would definitely affect your code. So it really doesn't matter on the schema changes as to whether you're maintaining it in the database or in the code. You actually end up doing it in both in a lot of cases. So I'll let you figure that out. We're going to go ahead and run this, and hopefully it'll build okay. So I'm going to let this build and deploy, and okay, so here we go. Everything's coming up. Looks like it compiled okay with no errors, which is good. And we're going to hit this with Postman. Let's see if it's up yet. We'll know it's all the way up because we get invalid API key. All right, so now let's go back and see what our, okay, 3211. So let's go ahead and try this. And we are going to get an error, actually. And what it says here is that this data type in varchar is not supported explicitly. You have to give it a size. So this is a little bit of quirkiness in the code generator for the models right now. And essentially where that's at is in this context class. And hopefully you won't have to do this. But there is for some reason, this error log entity has this invarchar that doesn't have a limit set on it, and Entity Framework does not like that. So I just removed that line of code. There's other ways to get around it, but I didn't want to dig into the details of exactly how to do this. One option is to just remove it. So we'll go ahead and take that approach. So you'll notice it dumped a big error here. So we're running again here. And should come up here just a moment. Because we made a code change, it's going to recompile. All right, let's try that again. So we'll send this again. And remember, our database is in Azure. We're using Azure SQL for all of this. And there's all of our wonderful data that came back from Azure via Entity Framework. Okay? Now, you may say, well, that's great for just getting back everything, but what do we do if we want to limit this and only get back certain things? So let's look at that real quick. So this call right here wants to get the data by ID. So what I'm going to do is copy all of this code. This is where you're going to want to create a class or something that deals with all of this so that you're not copying all this code around. But it's very simple. Right here you can put a where clause in. So we can say where c.customer ID is equal to the ID that was passed in. So what I did was I took the get that takes the customer ID as a parameter, and I added that filter in here. Okay? And we'll go ahead and run that. And I'll pause this until it comes back up. The thing I need to change is that this has to return a JSON result, not an address label. Okay. We'll go ahead and run that. Okay, we're running. So we know that our get will get back everything. We've already tried that. So I'm going to grab an ID here, this 29486, and pass that in like this. And we should just get back that one record. And we did. So everything worked. So that's how you can actually filter the results back. And now just to prove that we're still cross-platform and that we're only using Entity Framework Core, what I've done is I've moved this project over to the Mac, and I've built and run it. You can see here's all our models here that were created. And if we open up our controller, you'll see the code changes that we made in here. There's the Entity Framework code and link code that we put in. And I've then run that. So we got the invalid API key, and I have Postman running on the Mac, and I've gone ahead and run this, and it works. And if I go down here and grab one of these, just to show you that both calls work still. And again, in both cases, we're going to Azure for SQL Server to the database. So that's interesting. We have two customer IDs out there that are the same. Have to go investigate that a little bit further and see why that is. In any case, you've seen now that we have successfully used Entity Framework Core with our ASP.NET .NET Core application, and that it is cross-platform. It runs on the Mac and also runs under Windows. I won't take time to deploy it to Linux, but it would do the same thing there. I didn't have to do any configuration in Visual Studio. I simply copied the whole solution directory over and opened it up and ran it. All right, so I hope this was useful to you. There's a lot more to learn about Entity Framework and about Link, but hopefully this gives you a good introduction. Thanks for watching. Please like the videos if you do like the videos. Liking them helps support what we're doing here, and also if you would subscribe to the channels that are out there, that would help as well. Thanks so much for watching.